smaller, larger, all that kind of stuff. What's the relationship between the one triangle? Today we're going to get into it more with what happens when you have two triangles. Sir. For what? You're high on crack? Is that why you're tweaking? You know that's what that means, right? That's what a tweaker is. The tweakers are people not on meth. Sorry, crystal meth. Yeah, that's where that comes from. I know. That's where it comes from. Anyway.
The more you know.
Yeah. So when we're talking about two different triangles here, you can look at the relationship between side lengths and something again. This is something that is. It sounds like it's so unbelievably difficult, but yet when you see it visually, it is stupidly simple. Okay. For example, if I have a triangle. Is that legal to happen?
Wait, what?
Is that legal to happen? Just to have two triangles where they have two side lengths that are the same?
Yeah.
You're right. Yeah. That's. You okay there? Anyway, what can happen here, guys, is that you can have two triangles that have two sets of sides that are congruent. Triangle A, B, C, X, Y, and Z. And this doesn't necessarily mean that the triangles themselves are congruent. All it means is that you have two parts that are the same. Okay? Now, when you have that, between those two sets of congruent sides, they both have an angle in between them. Do you agree? Remember how we always call that an included angle? The angle between sets of congruent sides? In this case, those angles are not congruent. Okay? Because I'm saying they're not. So I'm going to say that this one is 83 degrees and this one is 27 degrees. You'd have to label it such. Now, which of the side lengths then do you propose is longer, BC or YZ? BC. It is quite literally what we're looking at today. What happens is when you get two parts of a triangle congruent, two legs, and we kind of did a little bit of this the other day when we opened up our hands and did the angle things. Usually your hands are the same size. I don't know if you knew that. Everybody's kind of going, I don't think they are. Yeah. Give or take, they're close-ish enough for us. Now, it's the same idea. The wider you open, the longer the segment would be between your fingers, wouldn't it? It's kind of what we're getting at here. All right. What happens is, this is a weird thing in geometry. It's called the hinge theorem. This thing called what we call the hinge theorem. It comes from the idea of a door. Because you have your doorway and the door itself. Last time I checked, this door is the same as the door in Lofthouse' room.
Yeah.
Okay? They're the same. Now, if I open my door up this much, and he opens up his door the whole way, which the door is still the same size, right? The opening is the same size, but the distance between the door jamb and the door would be different, wouldn't it?
Yes.
Now, if mine's only open this much, and his is open all the way, which opening is greater? And again, the reason being is because the angle of his opening is larger. That's the only thing that's going on here. It is a weird. His would be. His would be. It's another easy thing to look at like this. Now, do you agree, for our intents and purposes, that these two are the same things?
Yeah.
Okay? So if I happen to make one of them that wide, and one of them that wide, this is really difficult here. I hope that you can figure this out. Which one has a larger opening between the two? This one, correct? The reason being is because which angle is larger? This one. I know, it's a lot of math. Please stop being loud. So Hume's theorem is basically something like this. When you have two sets of congruent sides, the larger of the included angles, is that okay to write it like that? The larger of the two included angles has a longer side opposite. The idea that when you have two congruent parts, or two parts, when you have two congruent,
Wait, was that the
yeah. And it's that the idea of the diagram I just put up there a second ago. So when you have two different triangles, when you have two sets of sides that are congruent, the included angle between them always tells you which side opposite would be longer. Okay? Which one will have a longer side. It doesn't come up a ton, but it is one of the things that the new textbook does talk about. It wasn't one that we talked a lot about before. But hopefully, it's not that difficult. No, we'll be okay. So that. So if I look at this first set, do you agree that you have two sets of sides that are the same?
Yeah.
Do I have to separate you? Listen to me. Do you agree that you have two sets of congruent sides?
Yeah.
Yes. 7 equals 7, and 4 equals 4. I know I'm asking a lot here. Which of the two angles is larger, 125 or 78? Okay. Now, that means which side length will be longer, LN or OQ? And it's that would be the larger of the two. It is not. It's probably one of the easier things that we do. What's that? Yeah. You don't have to draw that. Now, just like what we've done with a lot of definitions and things, we said it going one direction. We also said it working backwards. So in this case, if I'm working this one backwards, it would be the following. You have two sets of sides that are congruent in a triangle. The third side, whichever side is larger, it has the larger angle across from it. So the larger angle has a larger side, the larger side has a larger angle. This is working backwards. Expect to phrase that. So going backwards, This is that. If I go backwards with this, if you have two congruent sides, would be a bad idea. If you have two congruent sides, the longer of the third side has the larger angle, opposite. It's quite literally working it in reverse. You have two congruent sides. Whichever third side is longer, the angle opposite is bigger. Okay. To go back to the idea of the compasses. I go back to the idea of the compasses. You know these are congruent. We know that these are congruent sides. One angle or one side appears to be larger than the other. Is it this one or is it this one? This would have to have a larger angle. This is really, really groundbreaking stuff. It also kind of is it's kind of a reason why certain things happen. You guys ever go on the, what do you call it? Not like a Ferris wheel, but you know the swings that go around, the swings, that one, they go up on the angle, they swing around. Well, that's why I said it's not like a Ferris wheel, but it goes around. Anyway, so if you think about it, there's the chain that you're sitting on, and there's you sitting on the swing. This part here is how far you're away from the center of it as it spins, okay? As it starts to spin, what's happening? It gets longer out, doesn't it? It gets longer out there, but do those two distances ever change? Those distances stay constant, but dependent upon angular speed. Yes, ma'am. Not necessarily. I mean, I know what you're getting at, but when you start when things start rotating, the angle at which they come out, it does have a little to do with it, but you're still reacting with gravity, and gravity doesn't change. So if you remember, if I were to drop the keys and I was supposed to and myself off the side of the building, we should, in theory, hit the ground at the same time. If you take out all resistance of wind and all that. But it's remember that what's the one where the floor drops out as you're spinning around? Centripetal zero gravity, whatever it's called. Yeah. I get it locked in. Don't worry. I'm really making sure I don't want to hit anybody. So the reason that it works is because of what's called. You guys ever heard of centripetal force? Centripetal force is the idea with how gravity gets put in there. As you're spinning around, gravity, you're counteracting gravity, so it doesn't change. Yeah. Yep. Sir. What do you mean? Guys. The reason that gravity works is that there's a constant pressure put on us to keep us down. Okay? So what is it, negative 9.8 meters squared, I think is gravity, the force of gravity. I think that's what I remember from physics. I'm probably wrong. And it's a constant rate. Okay? Gravity doesn't change anywhere. It has variances, but on Earth it doesn't change all that much. And that's why different things happen at different speeds and stuff. So that's the idea of like as something spins around, as you speed up, it brings it out further, and as you slow down, it brings it into here. So that distance that you're spinning, your radius is larger because you are spinning at a faster rate. All that stuff is kind of the reason why this works. And then as you go through the like in Algebra 2, we talk about what's called angular velocity, angular momentum. As you go into a pre-calc class, you talk about gravitational forces and why it all works together as it goes to it. It all depends on physics, and this is where it all comes from. It's pretty easy stuff to work with. Now, that allows us then to do something like this. To take where you have one A, yeah, it would be a smart idea to draw this one out, because these are the types of problems we'll have homework. What will happen here is we're going to ask you guys to figure out possible values of x that make this problem work. What are the range of values? When we talk about range of values, you've done this before. Remember we had to add this side, we would add values together, we'd subtract values for different possible side lengths. It kind of works the same when we worry about angles. Excuse me. So as you draw this one out, you'll notice that you have one set of congruent sides.
Yeah.
Is there a second set of congruent sides?
Yeah.
Reflexive side. Good. Yes. Everybody see that? Have you drawn that out? You got that. So you have two sets of side lengths that happen to be congruent to each other. Therefore, what you can do is the angle in between them, the larger the angle, the longer the side length. You okay with that? So of those two, which side length is going to be larger? The RS has to be larger, because that means the 60 is larger than the two angles. You okay with that? So can that angle at SUT be larger than 60?
No.
It has to be smaller than 60. So what we do here is we need to figure out what are the range of values. So I know that 60, it has to be smaller than 60. Well, what has to be smaller than 60? 5x minus 20. And we're going to solve the inequality for x, just like we were doing the other day. Because remember, we have an upper bound and a lower bound. Now, when you're solving inequalities, remember you solve them the exact same way as you would in a regular equation. The only time you have to worry about it is if you're multiplying or dividing by a negative, but in this case, that doesn't come up. I don't think it ever shows up in geometry, honestly. The first thing I do is add the 20. I get 80. Divide it by 5, and what do you get? 16, I believe? Okay. So that means, bless you, that means my value of x has to be smaller than 16. But what do I do then to figure out what it has to be greater than? What's the smallest angle it could be? What does it have to be bigger than? That's an x value. What does that angle have to be larger than for the low end? No matter what does it have to be larger than? 0. It has to be bigger than 0. Okay, so it could be 1. The lower value is that you just set it greater than 0. Oops. You set it larger. Please stop leaning on the back of the chair. Okay? Thank you. Because that angle measure has to be bigger than 0. Then you wind up with another inequality. Add the 20 and divide by 5, and what do you get? 4, x has to be bigger than 4, but x has to be smaller than 16. So the possible values of x, you'll always have a floor at 0 and a ceiling at whatever the other angle is when you're looking at these. So your answer would be x is between 4 and 16. That gives you all your possible values of x that would make that a true statement. Excuse me. You have a floor of 0 and a ceiling of whatever the angle is. It usually started, when you write compound inequalities, you always put the smallest number on the left, and then it's always 2 less than symbols, and then the larger number. Because this means that x is bigger than 4, but yet smaller than 16. Same idea. What is the range, what is the possible values of range of x for this one? You guys do this one on your own. What's the upper end on this one? What's the lower end? No, when you're working with the angles.
What?
The first one, the 3x plus 18 has to be smaller than 90, but 3x plus 18 has to be greater than 0. Okay? Yes, sir. Oh, okay. Move one sec here. It has to be smaller than 90, but it also, at the same time, has to be greater than 0. Okay. One of them will always be the angle, the other angle you're working with. Yes, ma'am. The right angle. Okay. So 3x is less than 72, so it has to be smaller than 24 on one of them. You okay with that? On the other end, subtract the 18. But it has to be greater than negative 6. Is it okay to have a negative value here? Yeah. Because a number that's bigger than negative 6 would be, I don't know, negative 5. You okay with that? What's 3 times negative 5? And what's negative 15 plus 18? 3. So the even though the value of x winds up being negative, it's perfectly fine because when you substitute that back in, you get positive values for your angles. Okay? So just like we've said before, it's not wrong if you get a value of x that's equal to a negative. You can easily use that negative by substitution to get it to go back in. So, like I was saying, if I say 3 times negative 5 plus 18, that means that this angle could be 3 degrees. That's what I'm getting at. Okay. So to write this out in terms of that compound inequality, you have your lower level, less than x, less than upper level. So that's how you write that out. Okay? Like I said, it's not very difficult to work with this stuff at all. Okay? And write down the It is on 336. Yeah, there's, like I said, there's not that much. Makes no sense. The first 5 are just, find out which one's larger than the other. And then the next 4 are what we just did. And then the last one is just doing a less than or greater than again. So shouldn't take very long to roll through. I know that Chromebooks have been having a bit of an issue like the past couple days from what I've heard. I heard it was a giant mess yesterday. I would make sure that you pull this up right now before anything else happens. Screenshot it, that way you can get into it. If anybody has been having issues logging into the system or the Wi-Fi, I have a way to fix that right up here, so just use that and go from there. Now, nope. Not any different what you guys have. So.
Yeah, it is. Yeah. Really is. Well, I'm not on here. Okay, like downstairs, like used to be frustrating. You don't get any.
No, they don't.
Like they do.
Nope.
The service is but
Nope. Yeah,
yeah, like okay, in this area downstairs, the service is really bad. So